Hello friends, so here is another question on KVL and KCL application. So we have been given the circuit diagram and we have been asked to find the voltage between these 2 points A and B. So again, basic KVL and KCL application, some common sense understanding of circuits, how circuits work, that we'll use to find the voltage between points A and B. So let us redraw the circuit again. So here we have the 5-volt voltage source. Again, here comes some basic understanding. Here we have a short circuited path, this, and we have a 3 ohm resistor. Now basic circuit behavior, circuit analysis rule, it says that current always takes minimum resistance path. Okay, so let us say we have like this 2 paths. Okay, we have a short circuited path, we have current I. So here what will happen, current will not take this path involving resistance R, but will flow through this short circuited path, this minimum resistance path, because here resistance is equal to 0. Okay, so this whole path, this whole resistance R, this becomes redundant, it is of no use. Okay, it gets eliminated from the circuit. So the same thing happens here. We have a 3 ohm resistance path and we have a 0 resistance path. So obviously current will not take this 3 ohm resistance path but will flow through this minimum resistance short circuited path. So this 3 ohm resistor gets eliminated from the circuit, it is not necessary. So we simply use this short circuited path. So this is 5 volt, this is 2 ohm, then we have this 8 volt and 10 ohm. Then we have 5 ohm, then we have 2 ampere, then we have 4 ohm. This is 8 volt, this is 10 ohm. Okay, this. So now basic application of KVL and KCL. So let us first assign the branch currents. Let's say the current supplied by this 5 volt voltage source is I1. I1 flows through this, I1 flows through this, polarity plus minus, and the same current I1 will flow into the negative terminal. Okay, here this one is 4 ohm. Okay, this one is 4 ohm. Okay, here also it is 2 ampere current source, so here also it is 2 ampere like this, 2 ampere, 2 ampere, and the same 2 ampere will flow into it. Okay, now like we have this whole thing we have discussed in the previous questions also. Here, as there is no closed loop formed involving this 8 volt and 10 ohm resistor, here the current will be 0 ampere. See, here I1 is being supplied from this 5 volt source, from the positive terminal it is flowing away, and the same I1 it has to flow into it. Here also from this 2 ampere current source, 2 ampere is flowing out and the same 2 ampere has to flow in. Any current flow through this 8 volt and 10 ohm path, it will disturb this whole equation, okay, the basic law of operation of electrical circuits. So that's why the current flow through this 8 volt and 10 ohm path, the resistance path, it is 0. Okay, so I have discussed it in previous, the same kind of situation has come in the previous questions also, where I stressed upon this point why this is 0. So this is the whole thing, okay, that. So this is the point A, this is point B. So now simply we have to apply KVL in the left hand loop and right hand loop. So KVL equation 1 for the left hand closed loop. So 5 minus 2I1 equals to 0. That implies I1 is equal to 2.5 ampere. This, then here it is 2 ampere, already we know 2 ampere is flowing through this 5 ohm thing, 5 ohm resistor. So now we have to simply apply point to point KVL from this point A to B. So how we will apply? Like this. Here it is point A, plus minus, this is 2 ohm, this is 2.5 ampere, I1 is equal to 2.5 ampere. Then we have 8 volt and we have 10 ohm, like this. Then we have this 5 ohm resistance with 2 ampere current flowing through it, that is B, point A, point B. So now when we apply KVL through this path from A to B, okay, the equation will be KVL equation, first voltage at point A, V subscript A, minus 2I1, second sign dominating method because we are moving from plus to minus, minus 2I1, okay, like this. Then we'll move here like this and then like this. Then it will be plus 8 because we are moving from negative to positive, second sign dominating method, minus 10 into 0 because 0 ampere current is flowing through this 10 ohm resistor, so 0 voltage drop, so this will become 0. Then minus positive to negative 5 into 2 because 2 ampere is flowing through this 5 ohm resistor, that is equal to minus VB, the voltage at point B, that is equal to 0. That implies VA minus VB, taking this to one side, is equal to 2I1 minus 8 plus 10. Okay, this 5 into 2, that is 10. 2I1 minus 8 plus 10. Now we'll substitute the value of I1, which is 2 into 2.5 plus 2, which is 2 into 2.55 plus 2, which is equal to 7 volt. This VA minus VB, which is the voltage between point A and B, is equal to 7 volt. This. Okay, so again, basic understanding of the behavior of circuits along with KVL and KCL application, we solve the circuit. First thing, when we approach the question, the first concept which we used is that current always takes the minimum resistance path. So that's why this 3 ohm resistor, it went out of the circuit. We replaced it with short circuited path. Then we assigned the current values, current flowing away from a voltage source and current flowing into the voltage source, they should be the same. Flowing away from positive terminal, flowing into the negative terminal should be the same. So we did that, I1. Then current flowing away from the current source and into it, that should be the same, 2 ampere, 2 ampere, that we assigned, that we did. Then we assigned the polarities, okay, which is very important. Current always flows from positive to negative, okay, because power is always absorbed by resistors. Another important thing, current flowing through this 10 ohm resistor, that is 0, because otherwise it would disturb the circuit equations. Then we applied KVL in the left hand loop to find the value of I1, which we did, 2.5 ampere. Current flow through this right hand loop is already known because it is given, the current source 2 ampere. Then it was the basic application of point to point KVL from A to B, which we did. We substituted the value of I1 and we got the result, VA minus VB is equal to 7 volt. Okay, this. Hello friends, so here we are with another question on KVL and KCL application. So it is comparatively very simple as compared to the other questions that we have discussed. So we are given this circuit diagram and we have been asked to find the value of this unknown resistance R. Okay, so here first let us say we assign the currents flowing through each of the following branches. Let's say the current flowing here, it is I. Okay, same current flows through the 10 ohm resistor with polarity like this, plus minus. Here it is 3 ampere given, 3 ampere is flowing into R. So here applying KCL at this node, this current flowing through 14 ohm resistor, it will be I minus 3 with polarity like this. This polarity is also like this, plus minus. This is 3 ampere, this is your I minus 3. Again these two get added and the same I, it flows into 80 volt. This is the basic thing. Now first we have to apply KVL in this closed loop, left hand loop involving 80 volt voltage source. Here we will apply KVL 1. So the KVL equation will be like this. 80 first, second sign dominating method, plus comes first, negative to positive, minus 10I plus to minus, that's why second sign minus, 10 into I, current flowing through 10 ohm resistor, minus 14 into I minus 3. I minus 3 flowing through 14 ohm, second sign dominating method, minus, that is equal to 0. That implies 80 minus 10I minus 14I plus 42 equals to 0. That implies 122 is equal to 14 plus 10, which is 24I. That implies I is equal to 122 by 24 ampere, which is equal to, if we calculate, it is coming around 5.08 ampere, this much. Okay, value of I we have got. Now we have to apply KVL in this second loop, KVL 2. So here it is 14 into I minus 3 plus 14 into I minus 3, because we are going from negative to positive. Second sign is plus 14 into I minus 3. I minus 3 is flowing through 14 ohm. Minus 3R is equal to 0. 3 ampere is flowing through R, plus to minus, second sign is minus, minus 3R is equal to 0. Now we'll substitute the value for R is equal to 14 into I minus 3 divided by 3. So it will be 14 into 5.08 minus 3 divided by 3. The result is coming around 10 into 5.03. It's coming around 9.706 ohm. Okay, that is the value of R. 9.706 ohm. This is the value of this unknown resistance. So it was very simple. No such kind of a conceptual thing was there where we have to twist and turn certain things. Straightforward KVL application. First, we assigned the currents flowing through the branches. Then using KCL, we determined the currents flowing through the other branches. Then after that, simply two KVL equations were there. We got the value of the current I flowing through the 10 ohm supplied by the 80 volt. We used the same value in the second loop and we got the value of R. Okay,